The following recording is a Somali Society of Engineers presentation conducted on November 1st, 2024. Engineer Mohamed Salah is a senior water and chemical engineer with over 30 years of experience spanning some of the world's leading engineering firms. He is a licensed professional engineer in the United States and Canada and holds a Bachelor of Science in Chemical Engineering from the University of Technology in Baghdad and a Master of Engineering Science in Chemical Engineering from Western University, Ontario. A published author, award-winning speaker, and international conference presenter, Engineer Mohamed Salah is a subject matter expert in a wide range of advanced water treatment technologies, from MBR and SBR systems to reverse osmosis and ultrafiltration. With project experience spanning multiple countries from USA, Canada, Asia, and the Middle East, he currently serves as Vice President of Process and Applications at BioWorks North America. In addition to his technological and professional background, Mohamed Salah also serves on the SSC Advisory Committee, contributing his expertise and knowledge to the advancement of Somali engineering and practice.
Thank you very much. I really appreciate it. And I want to thank the organizers of this event. This is really a great event. And I really enjoyed Rashid Goulet's presentation, which was wonderful, and all the insights that he has given to the youth. Mine will be a little bit different. It will be more of a technical, and I'll be touching different areas of the industry. So let me start sharing my presentation. Okay. What I'm going to talk about a little bit today is the interdisciplinary engineering for plant design. When it comes to a plant design, how different engineers work together. The plant can be a oil and gas refinery. It can be a food processing plant. It can be industrial wastewater. It can be municipal wastewater. It can be power plant. It can be any process. So how do engineers work together, and what do they deliver, and what each of them's assignment is basically. So before I do that, I just want to give a just general introduction. Those who are not engineers or students who are joining this gathering and want to become engineers in the future, there are actually main four engineering disciplines, which we call it basic engineering, which is mechanical, electrical, civil, chemicals. These are the basic engineering. And there are also focus engineering disciplines, which is basically a spin-off of those disciplines, like industrial, which is a plant operation and optimization, environmental engineering, which is civil and chemical, aeronautic engineering, which is mechanical, biomedical engineering, chemical and mechanical, mechatronics, electrical and mechanical, petroleum engineering, geology, mechanical, chemical, food engineering, which is food science and chemical, and instrumentation and control, which is electrical engineering spin-off. So these are, when someone wants to consider engineering as a career, they have to just think about whether they want to be just a general engineer, which is the four disciplines that I've just mentioned, or they want to focus on specific engineering discipline, like going to aeronautic engineering, or mechatronics, or petroleum engineering. So these are the main engineering disciplines and the spin-offs. So the next slide is when it comes to a process plant, project life cycle. Every project which is a process plant, it starts with the pre-feasibility study, and which is basically feasibility scoping. And then it follows feasibility study, which is optioneering, which is basically technology evaluation, selection, project site selection, high-level process flow diagram, not to exceed budget, scoping for front-end engineering, which is called FEED. Most of the people who are actually familiar with FEED are those from oil and gas. Other disciplines in municipal world, they use a preliminary engineering, but in the oil and gas, they use FEED, front-end engineering, which is basically a preliminary engineering. So it starts with pre-feasibility, feasibility, FEED, and then bid process and contract, EPC selection, and then followed by, and that's where the bid ends. And then whoever the successful bidder starts to do preliminary design, which is basically FEED verification, detailed design, construction, procurement, installation, and commissioning. So this is the life cycle of any process plant, from the beginning to the end. And there are different disciplines that contribute to this effort. During pre-feasibility and feasibility study, if it's a power plant, it will be a mechanical guy who will take the lead. If it's water and wastewater, it will be civil, environmental, chemical will take the lead. If during the feed study, which is front end engineering design, if it is the process plant, it will be chemical engineers who will prepare the process flow diagram, the PNID, which is piping instrumentation diagram, control philosophy, mechanical list, load list. They will prepare that. And the mechanical engineer will prepare mechanical equipment, piping, and the 3D. Electrical engineer for the plant will prepare the single line diagram, SLDs, substation, design of transformers, motor control center, MCC, cable routing, voltage drop calculations, and all that will be done by the electrical engineer. The civil engineer will do the plot plan, earthworks, structural design, architectural, utilities. Architectural, even though it's a different discipline, but a lot of people, they club it with the civil. And then the least engineering discipline that most of the people know about is instrumentation and control, which play a huge role in the process plant industry. They prepare the plant instruments, controllers, PLC, SCADA system. And these are mostly either electrical engineers who get trained or instrumentation control engineer. So this is just a basic process flow diagram for a wastewater treatment plant, sewage treatment plant. You can see you have got a coarse screen, finer screen, grease removal system, primary clarifier, bioreactor, secondary clarifier. And then you have the sludge goes to a digester producing a biogas, and the biogas is used to produce a electricity using a gas engine. So then treated water goes to a disk filter and use. This is actually a project that I worked on in the past, and this project is in the Middle East, and one of them is also in India. So basically, this is just general process flow diagram. This is also another one, which is a sequencing batch reactor, which uses also ultrafiltration as a tertiary treatment, and it's like thickening and dewatering. So this is basically what I said, process flow diagram. This is what I actually mean. Now, this is an actual process flow diagram that's part of the deliverables for the process chemical engineering discipline. And I'm not going to spend a lot of time on explaining what it is. I just want to give you a high-level understanding of how the different engineers work together in a project. Process engineers will prepare the design calculations. They will prepare the modeling and simulation for the plant. They will check before you build the plant, you have to make sure that it's going to work, and that's where the simulation and modeling comes into the picture. And then prepare the piping and instrumentation diagram. Piping and instrumentation diagram is basically the blueprint of the plant, and this is what chemical engineers will prepare. It will show the pipe size, it will show all the instruments required for the plant. It will show where we need to have MCC control, where we need to have PLC control. It will show all the instruments. It will show all the valves. It will show all the all the details of the instrument, whether it's a flow meter, a level transmitter, a pressure sensor, temperature sensor. All those need to be shown in here, and this is what everybody else is going to use downstream. This is the plot plan for this is a wastewater treatment plant plot plan. And you can see different contribution from different engineering disciplines. Civil engineer will take the lead in access roads, contours, utility when they're preparing the plot plan. Because the plot plan has to have access roads, it has to have, and you can see there are roads all over the place. The mechanical engineer will do the equipment installation, accessibility, piping, all of those things we look into. Preparing the plot plan of a plant. It's not only one discipline that will get involved. It will be multidiscipline, civil, mechanical, electrical, chemical, instrumentation control. All of them, they have to contribute. The electrical engineer will check the main feeder, the MCC, the cable routing, The chemical will check if any of those changes will have any impact on the process or hydraulics. Instrumentation control engineer will check if there are any corridors for the fiber optics for the plant, control room locations, and all that. So this is normally when we do this, it takes quite a bit of time to come up with semi-perfect plot plan for the plant, because all those disciplines have to contribute and make sure that all the corridors for utility, all the corridors for the power, accessibility, all those things have to be taken into account. This is just a hydraulic calculation spreadsheet that normally people would use to calculate the hydraulic profile of the plant, calculating the head losses for the gravity flow and also calculating the head losses for the pump flows. This is me sitting in this is in a place called Varanasi in India, where we did a plant. You can see on my left, it's a huge clarifier, and you can imagine, designing of that clarifier structure is done by the civil engineer, structural designer, and all the internals are done by the mechanical team. This is a plant in Dubai. You can see this is a digester, and we had a biogas production, and the biogas goes to this balloon, and from there it will go to, in this case, they are using to dry the sludge and produce a fertilizer. In other places, people will use this biogas to generate electricity and send it to the grid. This is in the US. This pulp and paper industry. Industrial wastewater is very important for pulp and paper industry, because pulp and paper industry uses a huge amount of water, and if the pulp and paper industry does not recycle their water, it will be very expensive to produce papers, because papers consume a huge amount of water. So what we normally do is we take the wastewater, we treat them, and then use it again and multiple times, so they don't have to draw water from the lakes and the groundwater. So this is very critical for the pulp and paper industry. This is what the mechanical engineer will do: 3D drawing, showing all the pipes or showing all the units, and it's a critical that nowadays, to see all the clashes between different disciplines when you have a 3D drawing. This is a typical thing like diagram for electrical engineers that they prepare for the project. And the single line diagram will give you an overview of where the power is coming from, and where you have transformers, and where all the distribution systems are. You can see this is a civil engineering structural for the concrete. So the civil engineer will design the structures and put together the structural analysis and produce the structural drawings that can be used for the construction of the plant. So the objective of this presentation is to show you a plant, a process plant, how many disciplines contribute to, what their backgrounds are, and just to give you a general flavor of the the area that I'm actually specialized, which is in water and wastewater treatment system. So that's my presentation in general. I just want to, I just like Guled, I've been in the industry, over 30 years. I work in many different places. Currently I'm working on Vivo base in Salt Lake City. Before that, I worked for Larsen Tubro, and I've traveled, extensively all over the world, building plants and training engineers and all that. So that's the conclusion of my presentation. Just want to give a little bit of advice for the engineers sitting tonight here. First thing I would like to advise them is that, your career is everything. You have to put your heart to it and be the best in the industry. That's the number one. The second thing is you need to help your peers. Somalis, when I started practicing engineering in Canada back in the early 90s, mid 90s, it was very difficult actually to find any Somali that you can ask anything, any question. And the people, at that time, could not, we didn't have anyone to mentor us. we were just on our own. We just have to figure out things on our own. But now you have got so many Somali engineers who can really help you in every discipline. So those who have got jobs, I would advise that they really have to seriously help others to get into the industry, get a good job, and also encourage those who are going to universities to really focus more in engineering, because as you all know, that engineering is only 4 years. It's not too long. Second thing is it's easy to find a job compared to other disciplines. So, and being a minority, I think it's always helpful to have a skill under your belt. So that's basically my advice with respect to the career. With respect to this organization, I think this organization has to grow fast, has to grow big. And I think Rashid has made it very clear that this organization can really provide a hand to those who need help, whether it's here in the US and Canada or elsewhere in the world, wherever the Somali-speaking people or Somali people are. So thank you for your attention, and I appreciate the opportunity to present here today.
This marks the end of our presentation. Thank you for listening, and if you would like to learn more or get in touch, please visit us at somaliengineers.org.